Today we're learning about solving literal equations. So the first thing you need to know is what in the heck is a literal equation? Well, all a literal equation is an equation that has two or more variables. We have been dealing for the last couple of lessons only in solving equations with one variable. Either 1x or 1y or 1w. Even if there is a w on both sides of the equation, there's only one kind of letter. In a literal equation, there will be an x and a y, or a w and an x, or whatever, even a w, an x, a y, and a z. Anything with two or more. So go ahead and I want you to look at number 1, number 2, and number 3 and determine which ones are literal equations and then explain your answer. So take a moment and pause your video to do this and then start it back up to check with the answers. Okay, so to solve a literal equation, we're going to follow the same steps we've been solving for solving equations. We've been following these steps. The only difference is you're not going to come out with x equals 12 or y equals 15. You're going to come up with an x equals, and then the answer is also going to have a variable in it, a y or a w or other letters in it. So your answers in literal equations will always have the other variables as part of the answer. So really quickly, just to go over the steps that you're solving, the first thing you're going to do is you're looking to see if there's any fractions to clear. So you're going to clear fractions, then you're going to distribute, then you're going to combine like terms, then you're going to collect all your variables that you're solving for on one side, and finally you're going to isolate the variable that you're solving for with multiplication, division, addition, subtraction. So those are still the steps. Nothing's changed. It's just that your answer will have a variable in it. Okay, so let's look at number 4 and work through that one together. So on number 4, it says to solve for y. I'll make it a little bit bigger. So if I'm solving for y, I go ahead and circle what I'm solving for. That just helps me remember. That's the thing I'm solving for. That's the thing I'm going to eventually isolate. So if I look, there's no fractions. There's nothing to distribute. I don't even have any like terms on one side or the other that I can combine. As far as collecting all my variables, the y I'm solving for is already over there and it's not on the other side. So all I have to do is isolate that. So I isolate the same way. I first start with isolating it with addition, subtraction. So since the 3y is the term I want to keep, I need to get rid of this plus 4x. So the inverse operation to adding 4x is subtracting 4x. Now, here's something interesting. When I go to subtract the 4x on the right-hand side of the equation, we have to remember what it means to be a like term. If I put this minus 4x here under the 9, can I ever subtract 4x from 9? Are they like terms? Can they be combined? And the answer is no. So a habit for you to get into right here from the beginning and for the rest of your mathematical career, put your minus 4x. Since there's not an x term over here, just put it over to the side. That way you won't be tempted to make a very bad mathematical mistake and try and combine terms that are not alike. Okay, so we just cross out our 4x's because they canceled out, and we bring down our 3y equals 9 minus 4x. Okay, now we're into the isolate phase still. We got rid of the plus 4x, but we're still having our y being multiplied by 3. So the inverse operation of multiplying by 3 is to divide every term by 3. And when I divide those, that leaves me with y equals. Sometimes it'll help if you just take a moment and think about what you got here. I'm going to even circle it. I got one fraction there, 9 over 3, and I got a second fraction, negative 4x over 3. If I can look at them as two separate fractions, a lot of times it'll help me. Okay, so 9 divided by 3 is 3. And then we already know that 4 divided by 3 is going to make an ugly decimal, so we're going to leave it as a fraction. So negative 4x over 3. There's my answer. So same exact process. The only difference is when I got to my answer, I still had a variable, but I got my y isolated all by itself. So that's my solution. Okay, so let's look at number 5. Number 5 is the exact same process as what we just did. So I want you to give it a try on your own. Again, you're solving for y. So use the process that we did and get to the answer and then check back. Okay, the answer was very straightforward. Main thing is make sure to be very careful about your positive and negative signs. Okay, so let's look at number 6. Number 6, again, very straightforward. So solve it, pause your video, and then come back and check your answer. Okay, in number 6, the biggest thing to be careful of is all of the negative signs. So it becomes really important. Just use the process I'm using of circling your fractions, including the signs. That helps you to see that your 6x is negative and it's being divided by a -3. You won't lose the negative divided by negative becoming positive. So it's just a good way to keep from making that mistake. Okay, number 7. Again, very straightforward, except now we've got 3 different variables. We're solving for w. So I want you to try this one on your own. It looks scary and weird, but follow your process and then check back and see how you did. Okay, what you notice is the process is the same. It's just that your answer now has 2 variables in it instead of 1 additional variable. The other thing is I wrote the answer 2 ways. I wrote it as p over 2, and I also wrote it as 1/2 p. If you look at the equivalent poster we have up above the number line in the classroom, study that equivalency thing and make sure you understand why those are the exact same thing.